Hey guys, I'm recording this video. I'm not the professor, I'm not a TA, I'm not affiliated with them anyway, so I could be completely wrong, but this is my understanding of dimensions and facts based off of the readings, what he's been saying, and my other experience. So I'm gonna try to explain it in a way that kind of bridges the gap between what we learned in 3360 with Stewart, 3355 with Gwen, even 2308. Anytime we've talked about normalization and actual databases, there's a clear gap between what we've been learned and what Professor Johnston is talking about. And so I'm going to try to bridge that the best that I can and in a way that take it from what we knew into what he's trying to describe. So a quick recap of what we know. I have a just sample table up here that it's filtered to just one order, but it could be full of all the orders where we have just what is the order, some descriptions about the order, and we can call these facts about the order, right? So we have an order date. That order date is specific to this order ID, right? Same with due date, ship date. And the customer is, same to this order ID. But these other variables, the email address, the phone number, they're really just part of that customer. They describe the customer, not the order, right? And as we keep on going here, we have where we build, where we shipped. And within that single order that I had this table filter to, each individual product that was ordered in there has its own line item. So that's why our table suddenly has 21 rows because 21 products were ordered. A lot of this data back here for the actual orders is being duplicated. And within each product, we have other things like its color, its category, its model. And in the past, we've been taught to look at this and go, well, that's not normal, right? Product color depends on product name, same with its category and its model. So we should really take those into their own table with unique product names and orders and or colors and categories and models, and then relate that back to this table. So we're not only being efficient at our storage, but if we want to make a change, let's say in here we want to change for this product, the color is actually blue. Well, if we made a mistake, it's actually blue. We can put blue in here now. And every time we reference that product, it will actually have the color blue instead of black. So that's true. That's how we would normalize a table. We would do that for everything, including our customer. We would have customer email address and phone number stored only once in a customer table, and we relate that back to what other tables where the customers used, give it a customer ID, all that sort of stuff. That's true. That is exactly what this database AdventureWorks 2016 is. That is it taken to its logical extreme, basically. We haven't seen a full database like this before. We've played around with some small things and we've experimented with it, but this is a full database of all that. I mean, that's why for each person, they have their own table for the state, their email address, their phone number, somewhere in here, person phone. This is it taken to the logical extreme. And while this is great for editing, for reading, writing, updating, and merging this database, all those cool things, we're analysts. We're just here to read it. So this is very inefficient for us to get basic data. Just to create this simple table here, I had to write a rather complex query. And that was just simple, basic information about an order. So when we tack on all these other attributes to it, our queries get large, our tables get large, and it gets really difficult to use it and analyze it. Especially when we get into this talk of dimensions to facts, right? We've been experimenting with one fact table, which is great because it's a lot of work just to build that one. But if we want to have multiple fact tables, but we want to filter them in the same dimensions, it's really efficient if we just had those fact tables fully built out. If let's say this is looking at orders, let's say we had a fact table for customer reviews, right? There's orders, there's reviews for those orders. Think of Amazon. AdventureWorks is kind of designed to model Amazon, so there's reviews for that. So we maybe have a fact review table. Well, a customer placed a review. So now that same customer ID is in that review table. Well, am I going to blow it out? Am I going to have their email address and phone number? It makes it really difficult for us to filter both of those tables to the same customer without having that middle table of our normalized customer to customer ID. So that's how we're going to organize our database for analytical purposes. We don't care about storage. Storage is cheap. We don't care about updating because we're not updating this database. We're not editing anything here. We're just reporting on. We're just reading it. So we're going to order it based off of facts or dimensions. And dimensions, all they are is just things that describe facts. An order is a fact. When that order was placed, the date, that's a fact. How many items was in that order? the order quantity for each item and how many items there are, that's a fact. That's part of the fact table. And a dimension where it's what customer, sure, the customer themselves is a fact, but the customer's email address, their phone number, those aren't facts. They describe the customer. They describe the fact table. So that's going to become a dimension. So looking at our bus matrix here, right, we talked about internet sales, how date can describe internet sales. Well, date can also describe just about anything. Date dimensions are probably the most bothered dimensions out there. So for customer support requests, was probably a date that request was made, or for reviews, there's a date that review is made. So that date dimension can describe any of these. And if we wanted to filter these tables to, maybe one particular day or one particular month, we could get the results. If we want to say, hey, just what happened in March of 2012, we could see what sales were placed, what support requests were made, what surveys people responded to, and product reviews, all by filtering one table that's related to all of these. Same thing with customer. If I want to look up Joe Schmo customer, I can see what internet sales he made, what reseller sales he made, his support requests, surveys, his reviews, all of this. So this makes it much more efficient from an analytical perspective to store data this way. We don't care if Joe Schmo's name is repeated 20 times in the database. We just care that we can filter all of our facts, all the numbers. If facts are usually mostly numbers or descriptive data that's specific to a single instance, like an order, we can filter all those facts to one single dimension or multiple dimensions, right? I can filter to a date and a customer. So Joe Schmo's, all of Joe Schmo's facts on this one date. So we want to store things like that. We don't care about it being the most efficient way possible for storage or editing. We care about the most efficient way for us to provide analytics on it, right? We use this term slicing. Slicing is a lot like filtering. It just cuts up that table. So, and I'll show you guys that here in a little bit. But let's go back to facts versus dimensions. So let's build out a basic fact table, right? We know we've pretty well established that we want to look at the orders. And the grain of that is the actual line items within an order. Now, if we had established the grain that, hey, all we care about is just the orders themselves, we don't care about the actual products or how many items were in that order, we don't care any of those specific things, then sure, we can create a fact table that just has one row per order. It'll have descriptive data specific to that order, like order date, due date, ship date, what customer, the bill to ship to address, and then just the total for that order. But we want to be a little bit more granular than that. We want to look at actually the line items within the order. We're not going to be any more granular than that, though. I don't really know what would be more granular than that. But that's the grain of our fact tables. We want to see each individual line item within each individual order. So that's where I started my fact table. I said, hey, give me the line item. And as you guys go through here, you see that the line items are actually unique across all orders. So line item 480 belongs to only one order ID. It's not going to be repeated. Not like a normal invoice. If you guys have worked with invoices before where each individual just starts with a new line item numbering system, this is truly each line item is unique. So each line item, number one, only exists once. It's unique. It's the primary key field or surrogate key, whichever one. It's a key and it's unique. And it's in this table. And so number one refers to a single product with a single unit price with a single quantity for a single order. Now that order, sure, the ship date is the same for that order no matter what line item it is, but there's no reason for us to split these apart. They're both fact. They both are specific to an order or to a line item. There's no reason to split it apart. We're not trying to be efficient. We're not updating this stuff. So it's okay that we have the same order date repeated and the same order ID repeated for every single time we observe that. Same with the customer ID and bill to address. Then we can create dimensions to describe this fact table that we made. So maybe the first dimension we want is, I'm sorry, let me skip. I had something else planned. So in the past, we're used to just joining on tables. So let's say I wanted to expand this customer ID. I want to know what the customer first name, middle name, and last name is. Well, we're used to just saying, okay, well, join on our customers. In this case, we have to go through a customer ID to customer ID middle table to get the person ID, which then relates to the entity ID, right? But either way, we're used to having to join on other tables, select the columns we want from those tables, And then we can get that data. So when we go from just a customer ID, now we have their name, middle name, and last name as well. And we can get any more information about this customer we want. But if we were to bring this whole table into Power BI or whatever BI reporting tool that we want, and we want to just filter the single fact table off of the single customer attribute, that would be okay. It wouldn't be the easiest, but that would be okay. But as soon as I start bringing more fact tables, if I want to also analyze the customer's review or their surveys or their customer support tickets, like I showed you guys in our bus matrix over here, if I want to do that, well, if each one of these fact tables also had a fully expanded joined on customer table, it gets really difficult to filter those without a single customer table to then filter our tables. And I know something we haven't really played around with before, but BI tools aren't designed in that method. They're designed like what Professor Johnson said with that Kimberly methodology. I think it's Kimberly. They're designed to have one table that describes facts. So if I want to say, well, filter these 5 tables to the name John Schmo, it's not really going to know what we're talking about. It expects us to have, we're going to filter one table to John Schmo, and that will filter all the other related tables, if that makes sense. And I'll show you an example of this at the end. So that gets really inefficient. For one fact table, not the end of the world, but the way you're going to have multiple fact tables in your database, you may as well set it up with the same methodology. And even if you're only going to do reporting on a single fact table, have the dimensions. It makes things easier and standard across all your reporting. But we're not even then. As we progress in this class, I fully expect that we will have multiple fact tables, multiple dimensions, and we want to filter all those fact tables off of the same dimensions. So it doesn't work. I mean, this works for a quick SQL query. This does not work for actual BI reporting. So let's create an actual dimension. We create our fact table up at the very top, that first query. Now let's create a dimension that describes, in this case, the customer dimension, right? Notice all these joins I have to do, right? Because we're coming from a normalized database and we're building onto it. Right? We're building really on top of it, if you will, this fact dimension database. Which he'll show us a little bit more about that. You can also think of this as views, right? We are just creating views off of these tables that are a little more aggregated. They already have the joins made, and we can call these views assignment or multiple times, right? So I create this customer table. Of course, now in this situation, yeah, each customer has their own rep. They got customer ID, they have their related business entity ID, and then first name, middle name, last name, all of the usual suspects that we expect to see whenever we call a customer. And I can do the same for our products, right? Products gets a little bit more complicated here. I decided I wanted to see, hey, what was the standard cost for the product? There's a table in there called product cost history. And I want to say, well, okay, what is the product cost right now? So I just said, hey, I used a CT, remember from previously, I said, hey, give me the product ID and the standard cost, which are columns inside of the product cost history table. And since that product cost history table, as the name would imply, has the price for each product throughout history. So each product can be in there many, many times with many different costs. If we increase the cost by product, add $10 on to a bike, now it's $110. Well, we want a record of both when it was 100 and when it was 110. And then there has a start date and an end date where it says, okay, it was $100 between May of 2012 and December of 2012, and then in January 2013, that start date to whatever end date, it was now $110. So I can say, hey, give it to me where it's currently active, where the start date is before today and the end date is after today, or the end date's null. A lot of times when I looked at it, I actually pulled up the table, the end date was null. Just mean, hey, if we had a start date, just keep that number until we change it. And at that point, they'll update the end date and put in a new start date and all that. A lot of times it came up null because this is AdventureWorks 2016. So I was using it in 2023, it kind of just stopped. Some of these end dates were put in and then no new number was put in. So we see a lot of nulls, but there are certainly situations where that standard cost does have dollar amounts in there and we can see it. So we can see it in a natural order. We can see, hey, this is the standard cost and this is what it was actually charged in the order, right? We wouldn't want to update the cost for each order to whatever the newest cost is, right? If I raise that bike by $10, I don't want all the previous orders to say that the customer paid $110 for that bike. I want to say whatever they actually paid for that time. So that's why we have the cost history that we can view. So I tagged that onto there, said, hey, just give to me wherever it's null using that CTE. and then I join that on to our full select statement there at the end, just sync that product ID. Subcategory category models. These are descriptive qualities about a product that we would want in a product view. And now I can relate the product ID back to our fact table. And if I want to filter to one product, this long sleeve logo jersey in large, right? I can then say, hey, filter the dimension, the product dimension to this one product, and therefore it will filter the fact table, the internet order history to that same product. See all the orders for a product basically. And if I also had related to the product dimension product reviews, I would see not only the orders, but also see the reviews for that product. That's why we need that middle table, this dimension, to filter both of them. So, okay, so I have here using CTs again, because I didn't want to create actual views. I could have just created actual views or actually created these tables. I'm just using CTs here, but I'm just going to show you a simple way that I can relate the internet sales to the customer. And oh, it's really not going to scroll for me. Thank you. The customer, there we go. The customer dimension and product dimension to fact internet sales. So everything above, all the CTs above here are just repeating the code from above from that fact and dimension table. This is how I have to do with CTs. I could have made them actual views that related them. I didn't want to mess around the database like that. So all we care about is the last little bit. I'm saying select star from fact internet sales, or join on customer, join on product off of their respective keys. There we go. And now I can see here, hey, for each order ID, here's a line number, the order date, due date, all this information, right? So we can get those information the same way, but I don't want to bring in this giant table into a BI tool. It does not work very well, but I'm sure we can still get the same information as if we had a normalized database and we joined on 30 different tables, right? This information is the same information as over here. It's just now instead of joining on, I don't know how many tables are. It's a lot of tables, right? Instead of joining all this and doing all these calculations and using our CTs and everything, we can just join on very simply our fact table and our dimension tables. And if I have a different fact table, if I have from fact, customer surveys, and I can still join on customer in the same dimensions to them. But let's see some more practically. I think this is something that is a big gap between Professor Johnson's knowledge and ours. He teaches a lot of grad students, right? So they've had their hands in some of this stuff before, whereas we haven't really been taught. We've seen the data, so we've seen the fundamentals that are building this knowledge, but we don't actually have the experience to know quite exactly what he's talking about. And the book is the same way. I think the book's really designed for people who've kind of already seen this stuff. I read it; it's not great. So right there with you guys. But let's take a look here. What if I brought in fact internet sales, a customer dimension, a product dimension into a BI tool like Power BI? So I've done that for us here. We see there's fact internet sales, the date dimension, the customer dimension, and I also brought in another fact table, survey responses, to really show the power of why we're separating facts and dimensions. So you can see they're related, just like this. For one to many, from our dimensions to our facts. That's typically how it is. I'm not going to say it's always how it is, but it typically is how it is, right? Our date dimension, something I haven't really talked about, but a date dimension is derived. It's literally just a table of every possible date from the beginning of time to the end of time, and then we'll just filter down that table to whatever dates we need. So we would say in here, hey, fact internet sales and fact survey response, give me the youngest, the oldest date. Maybe it's something in 2010 or something like that. I don't know. It's okay now. And then the maximum date, literally using the minimum max functions. Show me the oldest, show me the newest. And we would then filter the date dimension table to that. That's what we bring in. So that we're not bringing in a whole bunch, but we could. We could bring in literally every single date, and then relate it that way. And I'll show you. I think I even pulled it up here. This is something I stole and then built on from someone else, but it's something I use at work. So you see here, I start from the year 2000 and it goes for 15,000 days. And then whenever I actually pulls into a BI tool, I always filter it to that min and that max. So I'm not bringing in 15,000 rows, as you guys can see down here in the bottom right. I'm only bringing in however many rows are between and including my minimum and maximum dates from those fact tables. And it supplies a bunch of descriptive information about those dates, right? Imagine joining this on to your fact tables for every single date. That would be really messy, really hard to deal with. So we only have one date dimension, or sometimes we may have multiple. excuse me, remember those rule modelings if we have multiple dates within a table. Typically, what I've done, and I don't know if this is how it's supposed to be done, so Professor Johnson will have to teach us this hopefully in the future, but typically have one active date dimension relationship to that for each table. So for our orders table, they would say, hey, only relate order date to date dimension. And although you will relate due date and ship date to that, don't make them active, which again we don't have a lot of experience, but it basically says like we know the relationship exists, but it's not actually filtering it unless we specifically tell it to. And whenever we tell it to, it will ignore the active relationship. So we can switch it in certain scenarios. But a lot of times, whenever we try to do that, the BI tool kicks back at us because we're also trying to relate it another way. It's a little complicated. We'll get to it later, but typically it's that way. And then if we need to, we can bring on a specific date dimension for these other ones, or just have inactive relationship with the date dimension and just have one main one that way. But it works the same as all other dimensions. Whenever I filter the date dimension table, it'll filter all our fact tables to that same date. But here's the power. So I have a date dimension, I have a customer dimension, I have two fact tables, right? In our report here, I just have a simple counter. I'm saying, hey, give me the count of sales orders and give me the count of survey responses. And I can slice that or filter it, right? Either they're pretty interchangeable. Slicing is just cutting up a table, or filtering is just truly only bring it down to a certain amount. I can say, hey, give me all of the orders and surveys from 2012, and then from our customer dimension over here, right? I'm saying, hey, just give it to me for males or for females, right? Either one. And it's filtering both of those fact tables off of the same criteria. If I had in this Power BI tool the fact sales, if I had joined on to customer key the gender as well, and I did the same for a fact survey response, well, it would be confused. Which gender am I filtering on? I can't filter on both, or at least not efficiently. Much more efficient to just filter off of one table's gender and have it related to the other two. So that's kind of the main difference between what we know as normalization and making our tables as unique and easy to edit and take up the least space as possible between what an actual analyst wants to use. It's more efficient for us because storage, guys, is really, really cheap. And we're not updating data. All we're doing is reading it day after day. So we don't care if numbers are repeated. We just care if we can filter and slice and cut up our tables based off of certain dimensions. And I can do that across a wide variety of facts, right? And sure, not every time will a dimension apply to a fact table, but it will apply to more than one fact table. And if a dimension truly only ever applied to one fact table, then you could basically consider that a fact and keep it in there, or keep it as dimension just for simplicity's sake. It doesn't really matter a whole lot in the analyst's mind. Preferably keep it as a dimension, right? But you could, right? But again, don't do that, because in the future, a fact table will come your way and suddenly you have to convert to dimensions. So always keeping things in dimensions is a good way. So facts, hard numbers, right? An order was placed at this time by this person. That's a fact. Now, the person's email, that just describes the fact. It's not part of the fact. So we can keep that in a dimension table and relate it. But we don't need to bring in all 15 of these tables and relate them all in BI tools and play like that. We can make those into dimensions, cut them up into dimensions and facts, make it really easy for us to slice multiple facts off of the same dimension. So like in our hypothetical example here, what if we had product reviews? What if we had customer support requests? I can filter all of these facts off of the same dimension as long as the dimension applies to it. If it doesn't apply to it, just won't filter it. It's not the end of the world. So that is the main difference between facts and dimension. We don't care about normalization. We don't care about duplicating. We want to be efficient, not for storage, not for updating, but efficient for reading and efficient for analyzing. That's kind of the plain English claim or big difference. So I hope this helped. I'll try to go to office hours. There's office hours an hour before class. As you guys walk into the engineering building, that big circle area, kind of courtyard thing where you can look down to the floor below. He's in the conference room. It's on one of those sides. You big glass doors, you always see him sitting in there. I'll try to go to office hours Tuesday and review this with him and make sure that I'm on the same page. Because at the very least, if I'm not on the same page, then we're all screwed. Unless someone else out there has got it, in which case, please share. If you have anything to add to this, send it to group chat, make your own video, or text me or whatever. And together we'll figure this out. I think the big problem with our class is just there's a little bit of a gap right between what we were taught and what he thinks that we know or what he expects us to know. Because even the book, we've all read the book, or most of us have, and at least from what I heard from other people, is this book doesn't really speak to us because it's not speaking to us from where we were, it's speaking to us as if we were, a little more advanced. God, maybe we got our hands in this stuff. So it's very confusing for me, and I still don't feel very confident in it. So hopefully he'll spend a little more time just bridging that gap between where we're coming and where he expects us to be. But besides that, I think it's going to be a really good class. So reply to this if you guys have anything to say or anything to share. Besides that, I'll see you guys all on Tuesday.